name is Dr. Esther Trufan, and in this video, I'm going to demonstrate how calcium chloride may affect the freezing point of water and ice. So let's begin the experiment with our chemicals. We will be using calcium chloride, deionized water, and I have a big box of ice here. Next, we're going to look at our equipment, and for that, the most important thing will be a scale, because we need to know the mass of the ice, the water, and the calcium chloride that we're adding to our beakers. And as we get closer to setting up our experiment, we need to bring in our beakers. I will be using 4 beakers today. 3 of these beakers will have designated purposes. 1 will be for deionized water and ice, and 2 others will be the same amounts of water and ice, and some designated predetermined amounts of calcium chloride. And the final beaker, it doesn't need to be the same size as the others. I will be using to scoop out the ice from the container and transfer them in small increments into the beakers that they belong to. Because we're going to measure temperature, we need a thermometer that is able to record temperature below 10 degrees Celsius or the appropriate conversion to Fahrenheit or Kelvin. So for today's experiment, I will be using a Fahrenheit thermometer, which goes from -40 Fahrenheit and above. And then, because we're doing measurements of a solid, we will need a weighing boat. Or in this case, I will be using 2. And if you need to, you should use a scrupula or a spatula for the weighing process. So let's get started. First, we're going to begin by turning on our scale, placing our first beaker on top of it, then tearing the weight. This is a good time to open up your ice chest, scoop out some ice, and measure out as close as possible to 40 grams of ice. I have 39.43 grams of ice in my first beaker. And I will set that aside. Next, I'm going to place my beaker that has 4.75 grams of calcium chloride written on it. I will tear it. Then into this one, I will measure out another 40 grams of ice. This is a little more than I planned for. It is 43.91 grams. It is okay if we are close to 40, but not exactly there. The molality calculation will give us the right number as long as we record these masses correctly. So after we recorded our mass of ice, we're going to set our beaker aside, place our third beaker that has the 9.5 grams of calcium chloride on it, tear the scale, and transfer 40 grams of ice into it. And this measurement is really, really close. It is 40.25 grams. With all the ice amounts measured out, we can set our ice chest aside and move on to our next component, and that is going to be our deionized water. Now, the density of water is 1 gram per milliliter. So you could start with a great estimate of using a 10 milliliter graduated cylinder, measure out approximately 10 milliliters, and then pour it over and collect the mass. But it is very important that regardless of how you transfer your water into your beakers, you record the mass of the water that was transferred. So we start with our beaker labeled as deionized water. We tear, and then we add 10 grams of water to it, or as close as possible. I added 9.92 grams of water to my beaker. And with that, I set it aside. Next, I will place my second beaker onto the scale, tear it, and add to it approximately 10 grams of water. It is a little bit more. It is 10.83 grams. And then finally, I will place my third beaker on the scale, tare it, and add approximately 10 grams of water to it. I added 10.13 grams of water to my third cup. With all these masses recorded, now I can move on to measuring my calcium chloride. If there are any traces of water on my scale, I will clean that up first, and then place a weighing boat on top of the scale, tare it, and use my anhydrous calcium chloride to measure out 4.75 grams, or as close as possible to that, of calcium chloride. I measured 4.78 grams of calcium chloride. I will place it in front of the beaker in which it will be transferred into. Then I will place my next weighing boat on the scale, tare it, and measure out 9.5 grams of calcium chloride. I measured 9.47 grams of calcium chloride. I will place that in front of the beaker in which it will go. And now that I am done with all my measurements, I will set my scale to the side. I no longer need my water or calcium chloride or my beaker either, so I set those aside, and I'm ready to record measurements. The first and most important measurement is the water with ice. For the purposes of this experiment, I started with 10 grams of water and approximately 40 grams of ice to remain consistent among my samples. But because melting point is an intensive property and should not depend on the water or ice amounts or ratios, I could use any ratio, but for the consistency of this experiment, so that we have no doubt that the changes are in response to the addition of calcium chloride, I remained with the same amounts. So I will take my thermometer, place it inside my beaker, and give it approximately a minute to get to the right temperature, at which point I will record the temperature that will be the melting point of ice or the freezing point of water. In this system and this thermometer, the melting point of ice and the freezing point of water is at 33.8 degrees Fahrenheit. And with that, we are done with the first measurement. We can extract our thermometer, and it is best to have a paper towel next to you, because when you move on to the next experiment, you don't want even a little bit of water to be transferred between beakers. In preparation for the next experiment, we're going to take our water and ice slushy, and then we're going to transfer all our calcium chloride into it. It may feel a little bit more slurry-like. And when we think that it has stirred enough, even though there is calcium chloride on the bottom, we can place our thermometer inside and start monitoring the temperature. Now, at this point, you can record your temperature every 30 seconds and stop at the time when at least 3 consecutive measurements are the same and it went below the freezing point of your water and ice mixture. The temperature already dropped under 30 degrees Fahrenheit, and I will continue with the swirling and the temperature recording until as much of the calcium chloride dissolved as possible. Now my temperature is 27.0 degrees Celsius. And I still have a little bit of calcium chloride in the water that hasn't dissolved yet. If in the process of trying to record your temperature as it's cooling down, all your ice is melted, it is best to restart the experiment because you will not get a lower temperature. I will continue this experiment for another couple minutes, swirling to dissolve the calcium chloride and monitoring the temperature. And the temperature is still just barely below 27 degrees Fahrenheit at 26.8 degrees Fahrenheit. At this point, I will keep this going for a little while longer to ensure that 26.8 degrees Fahrenheit is truly the lowest temperature that my slurry will go to. Once I am done with this measurement, I can move on to my next one, in which I will combine the 9.5 grams of calcium chloride with my water and ice slurry, and I will monitor the temperature the exact same way that I did with my first combination of calcium chloride with water and ice. If you are using calcium chloride for this experiment and the one that you have available is not anhydrous, in your measurement, please adjust for the additional weight of the water so that the molarity of your solution would be similar to the ones that I made. Or should you go with the same exact amounts, be mindful that your molality values will differ from the ones that we created in this video.